Hi girls. Today we're going to continue our lesson in Unit 4, Lesson 2. Now if you recall with Lesson 1, we worked with data, but in that case we were working with single measurement variables. In Lesson 2, we've been working with two categorical or quantitative variables. So we have two variables in our data now. So today's lesson is Lesson 4.2.3, Analyzing Residuals, and we'll find out what a residual is in a minute. So I need for you to tear out pages 69 through 80 in your workbook and get some graph paper because we're going to be drawing some graphs. So pause the video, get pages 69 through 80 and some graph paper. All right, so let's talk about what a residual is. A residual is the distance between an observed data point and an estimated data value on a line of best fit. Sounds really confusing now, but before, when we were drawing a line of best fit, we were determining whether or not a line that we drew was a good fit for the data. Not every data point was on that line, if you recall. So if we measured the distance between the line and the actual data point, that distance is called the residual. That's all that means, because not every point ends up on that data. And we can take that information and create a residual plot, and that will help us understand whether or not the line we have is a good fit for that data. So we'll do a few examples, and I know it'll make more sense after we do that. So let's go to page 71 in your workbook. An example says, Pablo's science class is growing plants. He recorded the height of each plant each day for 10 days. The plant's height in centimeters over that time is listed in the table below. Pablo determines that the function y equals 1.73x plus 1.87 is a good fit for the data. How close is his estimate to the actual data? Approximately how much does the plant grow each day? So the very first thing we need to do is plot that data. And in your workbook example, you actually have that graph waiting for you down there. So let's take a look at that graph. And I want you to plot these 10 points. So pause the video. When you come back, have those 10 points plotted. All right, so now that you've plotted those 10 points, your graph should look like this. We've created our scatter plot. Remember, we're not connecting these points. This is a scatter plot of data. Now, when we look at this, we do notice that it looks like a linear function. And Pablo gave us an estimate for the line of best fit. So we're actually going to take that equation that he gave us, which was y equals 1.73x plus 1.87, and we're going to plot that line. So just create a small x and y table. I could plug in 1. When I plug in 1, I get 3.6. When I plug in 2 for x, I get 5.33. So let's go to our scatter plot and plot those 2 points. This is my 0 line, this is my 1 line. I'm going to go up to about 3.5, which is going to put me right about there. And then I'm going to go to 2 and 5 1/3, which is going to put me right about there. I only need 2 points to graph, so I take out my ruler, I line up those 2 points, and I draw my line. So go ahead and give that a try. When we're done, our line looks something like this. Now don't forget to label your axes, which is currently not done on your example. So our x values are the days. Our y value is the height, and it doesn't say that, but we should write in centimeters. So your graph will look something like this. Now the next thing that we need to do is determine our residuals. What does that mean? So, on a different piece of paper, on a notes page, we are going to create an X and Y table for all of the data according to the line that Pablo gave us. So his equation was y equals 1.73x plus 1.87. So let's create that X and Y table. And his was numbered 1 through 10. There we go. All right, so in this case, we have to plug in each one of these values for x. We could do that, it would take us a little while, but let's use our calculator to help us with that. So get your calculator, and when it looks like this, we hit our y equals, and we're going to plug in our function there. So 1.73 plus 1, oops, forgot to put the x in there. Don't forget the x is up here, xt, theta, and then the n. So we're going to click that. I'm going to start over. 1.73x plus 1.87. Now, we could graph it, but we know it's a line. We go to second graph, and that gives us our table of values. Now, my table of values happens to be off right now, so I need to fix this in my table set. There we go. All right. Yours should be just fine. So now I can complete this table very easily using the values from my table in my calculator. So when we're done, our table is going to look like this. So we have our x values and we have our y values. Now, the next thing that we need to do is we need to find our residual value. All right, in order to find the residual value, we have to go back to our original table. So here's our original table of values. And we have to take the table of values that we just created. So let me slip this one right in here. So when we look at these pieces of data, we have both of our tables. And now we need to take the original y value from the actual data and subtract the y value that we found from the line of best fit. So I would take 3 minus 3.6, and I would place that in a table. So let's go ahead and do that. So this is what we're calling our residual table. So I'm going to call this X, and I'm going to call this the residual. I didn't do a very straight line here. There we go. So again, we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I take my original value, 3. I subtract the value I found using the equation, 3.6, and I get negative 0.6. For number 2, I take my original value, 5.1, and I subtract the value that we found, the value that I found when I used the equation, 5.33, and that equals negative 0.23. I take number 3, original value of the point, 7.2, and the value from the equation, minus 7.06. That gives us 0.14. So I want you to go ahead and complete this table for the rest of these values. You have to go back to the other two tables, your original table and then the table that we just created just now based on the table in the calculator. So pause the video and complete the table. All right, now that you've completed the table, it should look like this. So we still have, as our x values, our 10 original days, and now we have our residual values, and that once again is telling us how far away is the actual point from the point on the line. Actual point, point on the line. Actual point, point on the line. Actual point, point on the line. So now that we have this new table, we're going to create a new graph using this as our x and this as our y. And I believe your worksheet has that table there for you on page 72. Yes. So go to that graph on 72. It looks like this. And graph those points. So our first point says it's 1, negative 0.6. So 1, negative 0.6 would be right here. Our second point is 2, negative 0.23. Negative 0.23 would be right about here. So I want you to graph those 10 points and complete this graph. Pause the video. All right. Now that you've completed that graph, it should look like this. Again, don't forget, we're plotting x and the residual for x as our y value. Now you'll notice this graph is all over the place. It doesn't look like anything coherent. The points appear to be very random. When you are plotting a residual plot, you want to see, are the points random? And in this case, yes, the points are random. And that's a good thing, because that tells us that some of the points fall above the line, some of the points fall below the line. So when you have a random residual plot with some positive points and some negative points, then you know the line you have chosen is a good fit. Okay? So it seems a little out of whack. You'd almost expect it to look nicer for us to say yes. But again, our residual plot that is random, let me write that down. It's a random plot. We have negative points and we have positive points. Tells us, yes, the line is a good fit. So that's going to answer our question number 5. Describe the line based on the residual plot. Same thing we wrote here. We would say it's random. It has negative points, positive points. So yes, the line is a good fit. And the final question says, use the equation to estimate the centimeters growth each day. Since we've decided that the equation Pablo gave us is a good fit, y equals 1.73x plus 1.87, we can estimate how much it's growing each day. The growth each day is the rate of change, and in a linear function, our rate of change is our slope. So we would say the plant grows 1.73 centimeters per day. All right, let's do another example. I know this seems like a lot of work and we have to do a lot of graphing and a lot of plotting, but it is a good way for us to figure out if we have a good line when we have our scatter plot. So let's take a quick look at example number 2. It says here, Lindsay created the table below showing the population of fruit flies over the last 10 weeks. She estimates that the population of fruit flies can be represented by the equation y equals 46x minus 40. Using residuals, determine if her representation is a good estimate. So again, with residuals, our very first step needs to be to create our table of values for our line. So the first thing we're going to do, we don't have to plot these points first. We're not going to plot the original graph. That's not always necessary. So we are going to take the equation that Lindsay gave us and find each of our x and y points. We have 1 through 10 weeks that she took her data, and then the y value for each of those. So next we have to take our residual from that. So in order to take the residual, we have to go back to our original graph, our original data, and line them up. So we have week 1, 50 was original. Week 1, according to the line, is 6. So again, we take these two values, we put those in a table. So 50 minus 6. So let's create that residual table again. And it will look like this. So we line up again for our x values 1 through 10. We go to our original table where it said 50, and our table of the equation, 50 minus 6 gives us 44. We go to our original piece of data for 2, which was 78. 78 minus 52 from the table of the graph. So now we're creating the very next table. So I want you to be creating this x and y table, which is again our residual plot. Take the original. Let's just go back and look. Week 7, our original was 238. Week 7, according to the line, is 282. So that's what we subtract. 238 minus 282. So let's continue. And when you have your completed table, we now have our x values and our residual values, which will be our y's on the next graph that we plot. So take out some graph paper. Look at the points that you need to plot from the table, 1 through 10 on the x-axis. And we have some negative values as low as negative 45, some positive values as high as 46. So you need to set up a graph that will accommodate that. Graph those 10 points, and when you're done, your plot would look like this. Now again, let's take a look at this plot. When we look at this plot, we notice there are some positive points, there are some negative points, but they don't appear to be random. That's the difference. You'll notice there seems to be a pattern that the points are following, and that pattern is definitely not a linear pattern. So that's all we're looking for right now. I know that some of you will look at this and recognize this as a quadratic, but that's not what we're looking for right now. Our question is it a linear pattern? Because that was what she estimated her equation to be, a linear function. And if it isn't a random pattern that has some above and some below, we know that it is not a linear function. That is not the line of best fit. This is not telling us that it's a quadratic or anything else. The only thing it is telling us is that the residuals show us that the equation that she proposed is not a good fit. Okay? So again, it doesn't appear to be random. That's the key point. Even though there's negative points and positive points, you can see that there is a clear pattern here and that that pattern is not linear. So our answer here would be that her representation is not a good estimate. Okay? So you'll see the residual plot has a U shape. This indicates that a nonlinear estimate would be a better fit for the data. That's all we need to say. So her guess is not a good estimate for this data set. All right, let's take a look at example 3. Anthony is traveling across the country by car. He keeps track of the hours he has driven and total miles he has traveled in the table below. Anthony uses the equation y equals 42.64 plus 42.12 to estimate his total miles driven after any number of hours. Use a residual plot to determine how well the line fits the data. Approximately how many miles had Anthony driven after 13 hours? All right, so again, the first thing you need to do in this case is to create a scatter plot of the data. So take out a graph, pause the video, and make the scatter plot for this data. All right, when you're done, now I hope you're doing these graphs because I'm going to check these as your homework on Monday. So please make sure you're making these graphs. I'm going to have you turn these in, and while you're doing some problems in class, I'll be going through these to make sure that you actually did graph these. So your scatter plot should look like this. It definitely looks linear, so hopefully the line that he selected will be a good fit. So the line that he gave us, we go ahead and plot that, and you'll see we can use two different points. Plug in 0 and you'll get 42.12. Plug in 1 and you'll get 84.76. Plot those 2 points and then draw a line through them. Remember, you only need to plot 2 points in order to draw a line. So it looks like it's a good fit just based on the line, but we have to check our residual plot. So again, we need to go back to our original data, here, 38, and we have to subtract away the difference. So the first thing we have to do is find all of our data points on the line. Again, you can use your calculator for this. Plug the equation into your calculator and you will get all of these data points. 1, 2, 3, 4, 5, 6, 7, 8, 9 data points. Once you have that, then you have to go back and line up the two tables again. My original for number 1 was 38. From the line, it's 84.76. So we would take the 38 minus the 84.76, place that in another table. So when we're done, our residual table would look like this. And these are the new points that we will plot on our graph. So create a new graph and plot these points. Pause the video and plot those. All right. Here is our plot of the residual of x and the residual of x. Take a look at it, and then I want you to answer question number 3. Let me find question number 3. Sorry, I meant question number 6. And question number 6 says, determine if the linear function is a good estimate for the data. Based on the plot that you just drew, is the linear function a good estimate for that data? So I want you to go ahead and answer that on your own, and I will check that in your homework tomorrow. All right, that's it for today. I'll see you tomorrow. Bye.